separation. So here industrial method. So industrial method, it is bosch process. Industrial method, it is bosch process. And here bosch process we will discuss in 3 steps. Bosch process will be discussed in 3 steps. Okay, so let us go for the first step. So in case of bosch process, here let me rub everything. So let it be a step 1. Bosch process step 1. So here we have to take producer gas, we have to take water gas. So here we will take coke with steam. Okay, so coke, here coke, red hot coke we have to take, white hot coke. This one it is means it is highly means with more energy, it is hot condition, and here have to steam has to pass over it, and it is the temperature is 1000 degrees Celsius. What we are getting? Carbon monoxide along with hydrogen. Here why this and this one? This combiningly known as water gas. And this one it is equimolar. Equimolar in the sense this carbon dioxide volume and hydrogen will be 1:1. Okay, so here passing steam over hot coke with 1000 degrees Celsius produces water gas. Step 2. In case of step 2, this water gas, carbon monoxide and hydrogen, it is water has to add here, or here what we can write, this one is to excess of steam has to pass, not water, excess of steam has to pass through it, and here this temperature, the temperature what is decreased to 450 degrees Celsius, and here we have to take iron oxide as the catalyst. Here Fe2O3 it is the catalyst, and promoter we are taking Cr2O3. Chromium oxide is taken as the promoter. So here what we are getting? We are getting carbon dioxide along with hydrogen. Here this delta symbol, it symbolizes that heat is evolved. Okay, so here what happens? First step we are getting carbon monoxide along with hydrogen. So that one, these two water gases with excess of steam. Here steam, but it is excess of steam we are passing, and temperature from 1000 degree it has reduced to 450 degrees Celsius. Along with that one catalyst, this is the catalyst here. So Fe2O3 is the catalyst and Cr2O3 is the promoter, it is taken. And now question arises, do you think all this carbon monoxide is converted to carbon dioxide? No. So here some percentage of carbon monoxide are also present along with carbon dioxide. So third step will be here, removal of carbon monoxide or removal of carbon dioxide, carbon monoxide from the mixture. Why this one removal? To get pure hydrogen. To get pure hydrogen, this one has to be removed. Okay, so first step, steam has to pass through over coke, 1000 degrees Celsius. Here water gas is produced, and here water gas, carbon dioxide, this water gas pass through the steam, or excess of steam has to pass over it. So here temperature reduced and we are getting carbon dioxide. Here all this carbon monoxide is not changes to carbon dioxide. Some of this carbon monoxide is still there. So to get pure hydrogen we have to remove carbon dioxide, carbon monoxide from this mixture. So how to remove carbon dioxide? So carbon dioxide can be removed by passing through KOS solution. Here passing through KOH solution. Now we have seen the purification. Carbon dioxide can be absorbed. So here carbon dioxide can pass through KOH solution. Here carbon monoxide, how to remove carbon monoxide? By dissolving. Here it can dissolving in ammoniacal cuprous chloride solution. Here ammoniacal cuprous chloride solution. When it is dissolved in the cuprous chloride solution, this carbon monoxide get dissolved and this one only hydrogen. Here what we are taking, this one will be carbon dioxide, carbon monoxide along with hydrogen. All this mixture has to pass through KOH solution. When it is passed through KOH solution, this one is the rough diagram I am doing this one. Here passing through it, here carbon dioxide get dissolved. Here what we are getting? We are getting carbon monoxide and hydrogen. Again what we are taking? We are taking this one as ammoniacal cuprous chloride. Why writing all these things? Okay, here let me write CuCl2 CuCl ammoniacal cuprous chloride solution. Here few drops of ammonia hydroxide it is there. So this one carbon monoxide get dissolved here. Then we are getting pure hydrogen. Okay, so this one it is the rough diagram how to understand this. So here also another process also there to remove carbon dioxide. How to remove carbon dioxide here? If we are passing this carbon dioxide through with high pressure through water, because carbon dioxide it does not dissolve in water at ordinary temperature. Okay, so if we are taking this carbon dioxide through water with high pressure at 20 to 30 atm in water, carbon dioxide can dissolve. So this is also another, this is first process, this one will be second process. So pure hydrogen we are getting, this is bosch process. Next method, another industrial method of preparation, electrolysis of water. Electrolysis of water. When we take this one water, it is not pure water. Pure water cannot be taken. Here we have to take acidified water. What does mean by acidified water? With water, few drops of sulfuric acid can be added to make it acidified. So why pure water cannot be taken? Because pure water it is bad conductor of electricity. That is why ions cannot be formed and electrolysis process cannot be possible. So for us, when we are taking water, this one dissociate in case of electric current passing, electric current. So it forms H plus ion plus OH minus ion. Okay, here at cathode what happens? At cathode, let us take at anode. Yes, so which one will move towards cathode? Hydrogen will move towards cathode. So H plus 1 electron give rise to hydrogen, it is H2. And here in case of OH, this one will be OH minus, here minus 1 electron give rise to OH. 4 such OH give rise to 2 water plus 1 oxygen. So hydrogen collected at cathode, oxygen collected at anode. So all these are the ways for the preparation of hydrogen. Now we'll go for uses of hydrogen. So first of all, case is hydrogen is used as a fuel. Hydrogen it is used as fuel. Why it is used for as a fuel? So here if it is used as fuel, it is in the form of coal gas, it can be in the form of water gas, it can be in the form of liquid hydrogen. Liquid hydrogen, it is used in rocket. Okay, so here these are used in the fuel. All these uses are give region questions. So why it is used as fuel? Due to high combustion, or it is highly exothermic reaction. So highly exothermic in nature, exothermic reaction. Okay, so it can be, so otherwise if it can be, it produces high heat of combustion, it produces high heat of combustion. That is why only all these are used as the fuels. Okay, next we will go for, it is used in the meteorological balloon. So this one is the first one. Second, meteorological balloon. In meteorological balloons. Why it is used in the meteorological balloon? Because hydrogen, it is lighter than air. Lighter than air. So it can move upward direction easily. But nowadays S2 is not used in meteorological balloons. Why? It is not used in the meteorological balloons. Okay, why it is not used? Because it is flammable, highly flammable. Because hydrogen is highly flammable, otherwise we can say this one is inflammable. Okay, that is why it is not used. Instead of hydrogen, nowadays helium it is used in the meteorological balloons. So helium is preferred in meteorological balloons. Why so? Because in this case, helium just after hydrogen, it is also lighter. It is, as it is less reactive. Then not less reactive. It is means inert gases. That is why it will not react. That is why it is helium is preferred over hydrogen. Hydrogen nowadays it is not preferred. Now hydrogen, it is used in metallurgy. Why it is used in the metallurgy? For the extraction of metal from its oxide ore, used in metallurgy. Next is third one, it is used in metallurgy. Okay, why it is used? This one, it is very important. Hydrogen act as a reducing agent. This one is important. That is why only hydrogen it is used in the metallurgy. So here, if I will take copper oxide with hydrogen, it can be copper plus water. So this one here also it can be Fe2O3. This one will be hydrogen. Along with that one, what we are getting? We are getting Fe with water. If we are getting here this one hydrogen, how 2 Fe2, so here it will be 2 3, okay, 4 6, this one will be 3 3 3, okay, this one will be, it is balanced. It is in the metallurgy for this one. Then another interesting comes, this one it is used in the welding purpose. Welding purpose, it is used in welding and cutting, welding and cutting of metals, of metals, welding and cutting of metals. So here it is highly exothermic reaction, exothermic reaction, and here this oxygen burns in atmospheric this oxygen burn in hydrogen, forming this hydrogen flame, and here temperature it is 2800 degrees Celsius. So obviously at this temperature it can be used for the cutting and welding of metal. And here also another one is hydrogenation of oil. So here hydrogenation of oil. Next one it uses hydrogenation. Here hydrogenation, in hydrogenation, vegetable oil, it turns to semi-liquid semi-solid fat by hydrogen. Here the catalyst used, it is nickel or platinum at 200 degrees Celsius. This one it is important. Here these are written it is the catalyst. Okay, next we will go for some other chemicals also prepared. Other chemical preparation of other chemicals. Ammonia can be prepared for hydrogen hydrogen along with nitrogen, it forms ammonia. In presence of iron as catalyst, molybdenum is the promoter. Here 250 to 900 atm pressure, here 450 to 500 degrees Celsius. So here 2, so here it will be 3. This one will be preparation of ammonia from hydrogen. Let us take hydrogen with chlorine in diffused sunlight. In diffused sunlight produces HCl. Here hydrogen with oxygen give rise to water as the product. Okay, so all these are the uses of hydrogen. Now we will go for test for hydrogen. This one will be test for hydrogen. How we know that this particular gas which evolves it is hydrogen? Test for hydrogen. So first of all the test is that pure hydrogen burns quietly in air. Okay, with a pale blue flame, forming water. Second case, what it will be? Second one will be hydrogen and air mixture. Hydrogen and air mixture burns with a pop sound. So this is the test for hydrogen. How we know that this gas evolves? It is hydrogen.